All right. So we are talking diesel today. Bonus module for diesels. So we're going to be going over diesel engines today. We're going to be going over diesel fuel systems, glow plugs, and how to diagnose a no start, hard start, or low power condition. So here we go. All right, so the diesel engine. You probably know this, but the number one difference between a gasoline engine and a diesel engine is the lack of spark. So a diesel engine self-ignites when fuel is injected due to a super high compression. So as the piston comes up, it actually is generating heat because it's such high compression that with compression comes heat. So just by this piston coming up in the cylinder, we have an enormous amount of heat already in the combustion chamber. And as soon as that fuel injector blasts diesel fuel into the cylinder, it automatically ignites. And that's how a diesel basically works. Another big difference between the gasoline and diesel engines is the fuel system. And we're going to explain all about that in just a little bit here. Diesel pistons have a recessed dome into the middle of the combustion chamber, and you can see that right here, where a gasoline piston is going to be pretty much flat on the top. These diesel engines have a dome in there. Basically, just to aid in combustion. It helps the air-fuel mixture swirl around in there. Also, diesel engines have a much higher compression ratio than gas, and that is to build more heat, kind of like what we just talked about. Diesel engines do have a tendency to be noisier than gasoline engines, and that is due to looser piston to cylinder wall clearances. Diesel engines just have a lot looser clearances, and so some of the noise we hear is actually called cackle, and what that is the piston kind of rocking back and forth in its cylinder, as it strokes up and down, and it just makes a lot of noise. That's called cackle. Diesel engines will last a long time if well taken care of. They'll outlast gas engines almost 2 to 1. It is not uncommon. I mean, 100,000 miles on a diesel engine is basically just getting it broke in. So it is not uncommon to get 300,000 miles plus out of a diesel engine if it's taken care of. So the diesel fuel system, let's talk about diesel fuel for a minute. Diesel fuel is less flammable than gasoline. Diesel fuel is actually kind of an oil. It's more of an oil than gasoline. It is less flammable. Diesel engine requires a ton of fuel pressure to the injectors. It's kind of one of the differences that we're going to get into. Different manufacturers have a different process of injecting fuel into the cylinders. Another little tip here is you're not supposed to use starting fluid on diesel engines. Supposed to is the key word. People do it. I haven't supposedly the reason being is it can cause damage to the engine. I have not personally seen it ever cause damage, but diesel engines, you're not supposed to use starting fluid. Although I may be guilty of that a time or two, but just throwing that out there. Okay, so mechanical fuel injection. This is the old school way of doing things. All right, so this system uses a timed pump to deliver high pressure fuel to the injector. And it's a poppet style injector. What that means, and right here is a picture of a diesel injection pump, and see, huge conglomeration there. And so the gear that is driven on the back side of this pump that you can't see has to be timed. The reason for that is because as this thing rotates, it actually pushes fuel. You can see 1, 2, 3, 4, 5, 6 here. Each one of these will have a steel line threaded onto it. So as this injection pump turns, it is opening valves and it is forcing fuel out each one of these lines, depending on where the gear is in its rotation. And I have on there, fuel injectors on this style are poppet style. So what that is, here's our fuel injectors. A poppet style means that it takes a certain amount of pressure to actually get the injector to pop open and spray fuel. For example, if it takes, and I don't even know, if it takes 1,000 psi before this injector will pop off and spray fuel, that's what it means to be a poppet fuel injector. So we can see this illustration here. We have our fuel line from the tank going through our fuel filter, going into our high pressure pump here, or our timed fuel pump here. We have our high pressure coming up, going to the individual fuel injectors in this black line here, and now this clear line here is actually a return or unused fuel. That's the return fuel. It just goes right back into the fuel tank. So that's kind of the old style, and each manufacturer has taken that and really done their own thing with it. So we're going to get into the different manufacturers and how they are injecting fuel into their engines. So we'll start out with a Dodge. So Dodge or Ram, the Cummins engine, and we're primarily talking about the 5.9 and the 6.7 liter engines. They're an inline six engine. One of the terms you're going to hear used is HPCR, and that stands for high pressure common rail. So this engine does use the high pressure common rail system. Okay, it uses a lift pump to feed a high pressure pump. So the lift pump creates 8 to 12 psi spec for low pressure pump. The 03 and 04 models have an external pump mounted on the frame rail. The 05 and up are internal in the tank. These engines use a high pressure pump, which is a gear driven or engine driven, sits in the left hand side of the engine block, and it is not timed to the engine. These high pressure pumps make a lot of pressure. We're talking 5,000 to 23,000 psi to supply the fuel injectors. Now these engines require a minimum of 5,000 psi to start the engine, and that's a very important number. I hope you're still taking notes right now, but I have created a cheat sheet for you guys that's we're gonna explain that in a minute with all the important numbers already on it. So also, the fuel injectors are electronically fired 20 amp 90 volt fuel injectors fired by the PCM, or ECM I should say. Here's an illustration of the fuel systems that Cummins use, and so you can see, let's just follow it here. Here's the fuel tank. Here's our fuel supply line going into our low pressure pump or lift pump. Okay, from there it goes to our high pressure pump. It goes through the pump, now it comes back out to the injectors. And right here you can see what we call the HPCR, the high pressure common rail. So we have an enormous amount of pressure in this rail right here. And you can see all the little steel lines coming off of this rail going to the individual injectors. Okay, so now we have all that pressure. Remember, that was the 5,000 to 23,000 psi going to these injectors. The injectors are controlled by the ECM, so when the ECM tells the injector to fire, it is now spraying that 5 to 23,000 psi out of the bottom of the injector. Here's a picture of the high pressure fuel pump. It is on the left hand side of the engine block. So you can see it right here. It is gear driven. So there's a gear right here that's driven off of the right off of the engine. So Cummins fuel injectors. The injectors are fired by the ECM. These injectors require 90 volts or 20 amps to fire. So a lot of energy to fire these injectors. High pressure fuel travels through connector tubes from the high pressure steel lines. So if we back up just a minute, I'm actually going to show you these tubes. You can see a picture of this connector tube right here. I'm going to back up just a little bit here. Okay, so right here you can actually see a picture of this thing. Our steel line comes and it dead ends right here, and what you can't see here is this is actually the cylinder head. So there's a banjo style bolt right here that threads into the cylinder head, and then there's a steel tube that goes through the cylinder head right into the injector right here. So it transfers that high pressure through these connector tubes, which mate right to the fuel injector. So we'll hop back over here. Now these connector tubes can fail. We do see sometimes that they get etched out right here, or loosen up and get etched out right here. And you can see where they sit right here. It's a tapered fit. When that happens, we typically want to replace both the connector tube and the injector to get a proper seal again, because these things have to hold such an enormous amount of pressure. So when these start to leak, now what's going to happen? If we have a leak, what happens? We lose pressure, right? So if we have pressure bleeding off around this hole, it's going out outside of the injector where we don't want it to go, where does that pressure go? So if these connector tubes leak, the pressure or the fuel is going to go into a return line, which is on the back of the cylinder head. So if we have a low pressure condition, one of the ways we can check where that pressure is going is to pop that return line off the back of the cylinder head, and there should be little to no fuel coming out of that. If we are blasting fuel out of that return line, we know we have a problem. Most likely one of these connector tubes is failing. All right, so we're going right into the GM Duramax 6.6 liter engine. And these engines are kind of classified they are high pressure common rail engines, but they are classified into different engine codes. So we have what's called LB7, that's the 2001 to 2004, and 8th digit of the VIN is number 1. The 8th digit of the VIN is always classifies the engine. So LLY is another one, 04 to 07. LBZ is the newer one, 2006 to present. And then LMM was only made for the 2007 year. Not really sure why. Okay, so interesting thing about the Duramaxes here is that there is no lift pump or no low pressure pump. So how does the fuel get to the high pressure pump? It actually gets pulled from the fuel tank through the FICM, or the fuel injection control module, which is providing cooling. It then gets pulled through the filter, which we have right here, and into the high pressure fuel pump. So believe it or not, that high pressure fuel pump is actually creating such a suction that it is pulling fuel the entire way from the fuel tank to the pump. And right here we have the sending unit, which goes in the fuel tank. And notice we have a couple wires right here, which is actually only for the gauge, for the level sensor right here. We do not have a pump in here. So what's happening is fuel is actually just getting sucked right through this thing. So this thing's nothing more than just a tube that sits inside the fuel tank to allow fuel to be sucked right out of it. So when I was first learning diesels, that actually threw me off a few times. I checked fuel supply at the high pressure pump. I'm like, oh, there's a problem. We don't have any fuel supply. We must have a low pressure pump pad. I remember one in particular. I said, yeah, I even told the guy kind of prematurely. He called and wondering, how his vehicle's going. I'm like, yep, I think your low pressure pump has failed. He's like, oh, that makes sense, Then I'd call him back and I said, well, kind of felt like an idiot, I'm like, well, so I had that all wrong. Your truck doesn't have a low pressure pump. It's actually pulled through the system from the high pressure pump. So it's just siphoned right out of the tank, basically. But anyway, so interesting how these things work. This high pressure pump is actually driven off the camshaft on these engines. It is not timed, so it's what we call a dummy pump. It is not timed. It also creates 5,000 to 23,000 psi of pressure. The fuel injectors are fired electronically 20 amp, 93 volts. Now this system has a manual prime on it because of the lack of a low pressure pump. It's got a manual prime, and that's that little button right there. So if you replace this fuel filter, which you can see right here, there's the fuel filter, it screws on, or for whatever reason you've opened up the fuel system, or even if you just have it where it won't, a diesel won't start, I'd always start here. You like to pump that manual prime about 30 times or until it becomes resistant. And one other little tech tip or note for you, I've actually seen these things leak, and it can cause a hard start. They leak right around here at the seal, and they don't actually leak fuel, but they leak vacuum. Now remember, we said the high pressure pump pulls fuel out of the tank. It actually requires a vacuum to do so. It's just like sucking, sucking out of a straw, sucking water out of a straw in your mouth. It's a low pressure, that's a vacuum. And so when you have a leak in your straw, even, the fuel's not getting pulled through the straw like it should. So that's a big thing on these engines. Any sort of vacuum leaks, so any leaks at all in the fuel lines can cause problems. So here's an illustration. We're going to go through this, starting at the fuel tank. So we get fuel pulled up out of the fuel tank. It gets pulled through this fuel injection control module, which is odd, but the only reason it does that is actually to cool the module. So they just have fuel run right through it. It goes through our filter separator. That would be our primer right there, that button. Now it goes to our high pressure pump. From the high pressure pump, it goes through our steel lines into a junction block, and then finally to our high pressure common rail right here and right here. From there, steel lines deliver the fuel right to the injector. So what's left over goes into these blue lines here, and that's the return line. That's the leftover fuel, and it goes back into the fuel tank. It goes through a fuel cooler first. It cools the fuel before putting it back in the tank right here. Okay, so here's a picture of our high pressure pump. High pressure pump sits in the V on this engine, and it's up front. This is the front of the engine. It's driven by the camshaft here. The little arrow we have circled right here is the pressure regulator. Just wanted to point that out. Every so often you have to service that or replace it. That's the pressure regulator right here. So on your scanner, you're going to see MPAs or megapascals. And GM uses this measurement to measure this high pressure fuel. And basically 1 MPA equals 145 PSI. So we use MPAs to talk about this engine. So this engine makes 30 to 40 MPAs at idle, which equals 5,000 to 6,000 PSI. The FRP, fuel rail pressure regulator, again, that's what we have circled right here. That's mounted on the pump. Ooh, the Duramax fuel injector. It's enough to make some guys cringe, because these injectors fail often, and they're really expensive. GM actually extended the warranty on these to 125,000 miles, usually. It's always a case-by-case scenario for whatever reason. And these injectors are really expensive, $400 to $500 a piece. And a lot of times you replace them all at once. When these injectors fail, what we typically see is hard starts, excessive smoking, and we sometimes see these things fail and it sounds like the thing's going to throw a rod out the bottom of the engine. They sound like a terrible, terrible engine knock when these things really let go and just start dumping fuel. These injectors are fired by the fuel injection control module, and they run on 93 volts or 20 amps. Okay, so we're switching gears here to the Ford Power Stroke 6-liter. These engines are inherently known to have kind of a lot of problems, but some guys love them, a lot of guys hate them. That's kind of how that works. And let me back up for a minute by just saying diesel engines, You're either going to have customers that use these vehicles for work, or basically guys that get into the big diesel truck and lift them up and put big programmers on them and make them go fast. But there's big money in diesel because both these customers seem to not have a problem paying big bucks for repairs on these engines. So, diesel is a good thing to learn because there's a lot of money in it, and it's just another cool thing that to be able to say you service diesels and you work on diesels. So another skill to put under your belt. Okay, so got off topic there. Getting back on track here, the Ford Power Stroke 6-liter engine. Okay, so these engines, again, we're talking about the fuel system on these things. This thing has an external, mounted on the left-hand frame rail, external pump that delivers 50 to 60 psi to the cylinder heads. Now, Fords are a little bit different in how they work. Fords actually use a super high pressure engine oil is used to help fire the injectors. This high pressure oil is produced by a high pressure oil pump and then sent to the fuel and then sent to high pressure oil rails. Fuel injectors are controlled by the fuel injection control module. So there is no high pressure fuel pump on these engines, just a high pressure oil pump. But I'm going to show you how that works. Okay, so here's an illustration to help show you guys kind of how the system works. So starting from the fuel tank, we got fuel getting drawn out of the tank, going through our low pressure pump. Again, that's making 50 to 60 psi. It's just looping right through here. It's going through a fuel filter, and it's going into our injectors through the cylinder head. This line right here actually represents a chamber that goes through the cylinder head, and that chamber goes right into the fuel injectors. So it goes right into each fuel injector, 50 to 60 psi, going right into the injector there. Okay, so now we have our high pressure oil pump. And you can see, we have our oil going into the oil pump. And our red lines here are high pressure engine oil coming out of the pump. Our high pressure engine oil goes on top of the injectors, and it sits there waiting for the injectors to fire. When the injectors fire, that high pressure oil goes into the injector, forcing the piston down, squeezing the fuel that's in the injector here and spraying it out the bottom. So that's kind of a unique system, kind of odd how it works. We're going to talk a little bit more about it here. So let's talk about this high pressure oil pump. This thing's kind of crazy. It's gear driven. It is non-timed. It sits in the rear of the valley. And you can see it right there. It sits in the rear of the valley. It's covered. There's a cover that goes over top of it. That's removed so you can see it. This thing creates 500 to 4,000 psi of engine oil. That's a lot of engine oil. It actuates and controls the injectors. That's what I mean when it actually uses oil pressure to fire the injector. Special note for you here, crappy or low, it's supposed to say low right there, crappy or low engine oil levels can cause runnability issues on the engine. Sometimes it's best to start with an oil change. So if you guys get a runnability issue in one of these Fords, and you have a funny feeling about the oil, is it on the low side? Is it, the oil change sticker is faded, it looks like it's been on there for 5 months, whatever the case, if you have a funny feeling, sometimes it's best to just start with an oil change. I've heard that the dealerships, whenever one of these trucks comes in for a runnability issue, they just automatically start by changing the oil, because one thing you don't want to do is just run around chasing your tail when it's something as simple as an oil change. So keep that in mind. Okay, let's talk about these Power Stroke fuel injectors. So we have low pressure fuel entering the fuel injectors between the O-rings right here. You can see that little screen. We have a low pressure fuel entering the fuel injectors right there. A special note on that. So we need 50 to 60 psi here. If it drops below, for whatever reason, if we get below that 50 to 60 psi, we can start damaging injectors. So it's important that we have 50 to 60 psi right here. So the fuel injection control module commands the injectors to fire 20 amp 48 volt signal. Like we said before, a high pressure engine oil. So you can imagine the high pressure engine oil goes right here into the top of the injector. A line enters right here. So that high pressure engine oil forces a piston down inside this injector. You can imagine a piston sitting right here. So when this injector fires, it allows that high pressure oil to go in here, forcing the piston down, squeezing this fuel in here to a super high pressure. It squeezes that fuel, causing it to spray out of the bottom of the fuel injector. Fuel sprays out of the bottom of this fuel injector actually at 28,000 psi. So you can see how Ford has designed this thing to work. It's kind of crazy, but it's kind of cool. So we took 50 to 60 psi, and using the force of our high pressure engine oil, we created a 28,000 psi spray pattern to come out of the end here. And the whole idea behind that is we want the best fuel atomization we can, and the higher the pressure, the better fuel atomization, the better combustion we get. So that's Ford's idea, and it works pretty good. Okay, so let's talk about glow plugs. What do we need glow plugs for? So glow plugs are designed to aid in cold weather startups. So there's a pretty easy way to test if the glow plugs are working. Basically how we do that is you need an amp clamp, and it has to be a DC amp clamp. A lot of the cheaper amp clamps on the market are AC only, so you have to find a DC amp clamp. I think the one I purchased, it was like $67 from Amazon. Again, DC amp clamp to measure DC amps. And we want to measure our amperage draw. So you just want to clamp this around the positive battery cable. Okay, you don't want to pinch the cable right here. You want this to actually loop around the positive battery cable. And then we measure the amount of amperage when the glow plugs turn on. Now these glow plugs take a ton of amps, so it's pretty obvious if they're working or not. You want to test this cold whenever possible, especially like first thing in the morning is the best way to do it because you're going to get the strongest, longest signal to your glow plugs. So test cold. Sometimes glow plugs only come on once, every cold start. And another thing is it does take two people to do this test. You want to go out there with somebody who can turn the key for you, not start the engine, key on, engine off, and you should see the glow plugs come on and cycle for about 10 seconds or so and then turn back off. And that's just getting those glow plugs red hot in there, getting that engine ready to start up. Glow plugs, if you've ever started a diesel engine, a lot of times you turn the key on and there's a little kind of a swirly mark. That's actually a glow plug indicator. Some vehicles, some manufacturers actually have a wait to start light that comes on in the dash. So you turn the key on, you're supposed to wait for either that orange squiggly mark to turn off or wait for the wait to start light to go off, and then you can start the engine. Okay, so here's the best part. When you get one of these vehicles in with either a no start, a hard start, or a low power condition, we're going to help you turn one of the most intimidating, toughest jobs into one of the easiest jobs. And I'm going to give you the key to success right here. Believe it or not, guys, this is a lot easier than you think. So you have a diesel show up at your door. It's a no start. Most techs are going to be like, oh geez, where do I even begin with this thing? It's a diesel, I'm not really used to it. Nope, it's a lot easier than you think. After this class, you might even be the diesel specialist at your shop. First thing you want to do, pull out your cheat sheet that we made. and start going down the list. Okay, so let's talk first about a no start. The thing will crank and crank, but it will not start. So first step, is there enough fuel pressure, again high pressure fuel, to start the vehicle? On every manufacturer, I believe, get in there with your scanner, and as you're cranking it over, you can see our fuel pressure, our high pressure fuel pressure on the scanner. And on that cheat sheet, I give you a minimum to start. It takes a minimum of blank, 500 psi for some, to start this engine. So do we have enough pressure to start the vehicle? If not, first thing I do is check my supply pressure to my high pressure, so my low pressure fuel to my high pressure pump, to see if I have any fuel at all there, and if I do I have enough pressure? For GM, that's a little different. Remember, that system uses vacuum. So you can actually hook up a vacuum gauge. There's actually a test port right almost front and center in the engine. It's a great big test port, and if your shop has the correct vacuum gauge, it is really, really helpful. You plug it in right there, and as you're cranking it over, you need to see 2 to 10 inches of vacuum. And you'll see that on your cheat sheet where it says low PSI pump, we actually have vacuum on this one, 2 to 10 inches of vacuum. And if you do not have that vacuum, that means that basically means you have a straw with a hole in it, right? So you're sucking, but you're not getting anything there. So you need to have that vacuum. On a perfectly working system, you'll have 2 to 10 inches of vacuum, and that's what it's going to take to draw that fuel all the way from the tank to the high pressure pump. So if the vacuum's not there, now you know what to do. Look for a leak somewhere. So look for a hole in your straw, right? So that makes that pretty easy, but okay. Let's back up again. Is there enough pressure to start the vehicle? If not, check our supply pressure. That checks out okay. All right, so now what? That means we're not making enough pressure. So that boils it down into basically two things. We have a pressure leak, or we have a weak pump. If our pressure isn't there, so we're going to pretend we're talking about the GM Duramax right now. Minimum to start, 1500 PSI. It takes 1500 PSI for this thing to start the engine. So we don't have that. That means we either have a pressure leak or our pump is weak and it's not making enough pressure. Okay, so what if our low pressure checks out or our vacuum checks out, but we still don't have enough high pressure to start the vehicle? So what does that mean? We don't have enough high pressure. Well, that means we either have a big leak somewhere, so our pressure's bleeding off somewhere, or our pump isn't performing, our high pressure fuel pump isn't performing. The first place I'm going to look for is a leak. So if we have a big leak somewhere, a lot of times the first place I'm going to look is the fuel injectors. Is the fuel injector itself leaking? So if we do suspect a fuel injector leaking, one of the tests we can do is taking this special tool made by Miller, part number 9011, find that on Amazon also, and we can actually block off that fuel line. So now we're stopping the leak. So if we suspect that and we block off the fuel line, we stop the leak, and the engine fires right up, bingo, you just found your problem. Okay, if we have a hard start condition come in, so hard start or an extended crank, customer says, yeah, it takes me 2 or 3, sometimes 4 times of cranking this thing to get it to start, then what are we going to look for? A couple things we're going to look for: glow plug operation or air heater for Fords. Fords do not use glow plugs. Instead, they use an intake air heater. So a great big element mounted in the intake. It just gets super hot as the engine's cranked over. It heats up that air going into the engine. So it's just another way of doing it. So that's the first thing we're going to check for a hard start. We also want to check for lower than desired fuel pressures. Again, high pressure fuel pressures. And because that also can cause a hard start if it's taken a long time for our pressure to build up enough to actually make the engine start. So keep in mind, are there any other symptoms? Smoking, low power, etc. So I remember one we had a Duramax, ended up having to do a whole injector job. It was at the early stages, but what it was doing, it was a hard start. It actually came in for a hard start, and we also noticed that it was smoking a little bit. You just have a little extra smoke at idle, a little extra smoke on acceleration, and so what we had going on was the injector was leaking enough that when we're starting to start it, it was just taking a really long time for that pump to overcome that leak to build up enough pressure to start the engine. So let's talk about a low power condition. Customer brings in his diesel pickup, said this thing's just not making as much power as it used to. So where I'm going to go first, we're going to check the fuel pressure, the high pressure under a heavy load or wide open throttle. So get in your scanner, find your fuel pressure, go drive the thing, stomp on the throttle and watch that fuel pressure. Is it dropping below our spec? Is it staying okay? Another thing, real common one that could cause low power conditions is check for a boost leak, a turbo boost leak. And that's going to be anything between the turbo to the intake manifold. A lot of times it goes from the turbo through an intercooler up front and then finally to the intake manifold. So there's a lot of plumbing involved there. And if any of that plumbing develops a hole or a crack, we now have a boost leak. It's going to make the engine run with lower power. It might smoke a little bit more. So how do we find a boost leak? First thing and easiest thing to do is listen for it. If you torque up the engine, or what I like to do is put it in drive, step on the brake, step on the throttle, almost like you're about to power brake it, and just torque up the engine, get the thing spooled up a little bit, have somebody else do it maybe, and listen. And if you hear a real loud hissing noise, an air noise, try to find that. That could be your boost leak. Another way is just inspect it, look at it all real closely. A lot of times I've just been by visually inspecting it, I'll look at a intercooler pipe, and as I'm looking at it, I'll maybe move it just a little bit or look, and sure enough, it's rubbing on the frame right there, and I can see it's rubbed right through the aluminum pipe or the rubber hose, whatever the case. Another thing you can do is smoke test it. So you can fill it up with smoke and check to see if you got any leaks. That's a good test as well. Also, while you're driving it, you can look at your boost pressures, and if you have lower than expected boost pressures, that could be also a symptom of a boost leak. Not always though, because sometimes we can have a boost leak and go drive it and it's not enough to actually notice the difference on the boost pressure on the scanner. You go drive it, boost pressures look okay, but we do in fact have a boost leak. All right, so there we have it. Diesels in a nutshell. That was easy. So diesels are a little bit different to diagnose. They're also a little bit different to repair. But remember, guys, it's just nuts and bolts. There usually is a lot of plumbing around a diesel engine, so a little bit more stuff to take apart when you actually have to make a repair. Some of the real common repairs that we have is especially the GM or Duramax injector replacement. We also have to do head gaskets on those engines quite often. So the head gaskets is quite a job. You can either remove the engine. Some guys do a cab off repair. They actually remove the whole cab of the vehicle to do head gaskets on these Duramax engines. What I've found to work the best actually is to remove just the outer fender, just to remove the front fenders, the fenders and the inner fender plastic, and you can gain access that way to do head gaskets in the vehicle. The Ford engines, there is a lot of guys that do the cab off repair on the Fords to do injectors or whatnot. So, it's a little bit more involved, but again, they're really good paying jobs. So if you can, actually handle the repair, it's a good money maker for you. So good luck to you guys. And if you do get a diesel coming in the shop, remember, don't overthink it. Use your cheat sheet. Keep that sucker tucked away in your toolbox. And please don't post it all over the internet. I want that to be for you guys only. So Anyways, hope you enjoyed that. Good luck.